popularized math and history and was gonna celebrate the Chinese New Year. So you would say 新年快乐 in Chinese, because that means Happy New Year. So, the Chinese celebrations actually started in the 14th century BCE during the Shang Dynasty. Long after the Shang Dynasty ended, there's another dynasty that's also known as China's Golden Age, and that's called the Tang Dynasty. So what we're gonna be doing is we're gonna solve a math problem that's related to the Chinese New Year. So, but wait. Since we are learning about the Tang Dynasty, and it also reminds me of something you might learn in geometry. So, if you take a look at the word Tang, that also reminds me of the tangent, because the names of the two words or the two names have basically the same letters. So, there is a Tang Dynasty emperor named Emperor Zong. He ruled Tang China from 713 to 756 AD, and he was an emperor that was known for his love in art and music. So he once wrote a story that became a legend where a Buddhist or a Taoist monk came down from the moon to greet him, but then invited the emperor to go to the moon palace. So the Buddhist monk would throw his staff and it magically turned into a silver, sparkling bridge. When he got to the palace, he was memorized by what the orchestra inside the palace was playing, and he asked the monk what the song was called, and he said that it was called Rainbow and Harmony, so he didn't want to forget the memory. He came down back to Earth, and the emperor actually wrote a script, and he actually continues to play it during his reign.
On the north bank of the pool is the Zuyu Pavilion. It's a tasteful and quiet place, suitable for artistic creation. It's said that Emperor Xuanzong once dreams of wandering through a palace on the moon, where he encounters beautiful fairies dancing delicately. The dream inspires the emperor to create a dance drama, incorporating musical elements of the western regions with those of India. The emperor writes the music.
But wait, when Emperor Xuanzong was playing the flute with his wife, and he was also dancing on some sort of carpet or a rug, he notices that the rug has a circle and lines that intersect the circle. So, what we're going to be doing today is we're going to prove with the circle and the lines, prove that line AB, so AB is perfectly perpendicular to line CB, because there were lines on that rug with the circle. So how do we prove that? Well, in the first place, if you remember what perpendicular is, perpendicular lines happen when there are two lines that intersect with each other, but they must have an angle at 90 degrees with each other. So, with that, perpendicular lines can only be recognized if the lines are 90 degrees. And if you ever go to geometry or learn geometry, this symbol right here is the perpendicular line symbol. So we need to prove that right over here and right over here is 90 degrees. If you look at a photo, that's great, but sometimes when you're working on a math problem, that photo might be false. So we gotta prove why this happens. So the first thing we gotta recognize is that circle is intersecting the line. And we're gonna place a dot right in the middle because line A and B is also gonna have a dot or a segment here that is connecting the two shapes together. But what happens if we try and put another dot somewhere else? Type in the comments below what you think where the dot should be on this line. Well, what we're gonna do is place a faraway dot right here. And what we're gonna be doing is calling it dot C or point D. Because here's C, there's D, we already used A and B. So what we're gonna be doing is how far distance is A to D and how far distance is A to B. Well, we know what the distance from A to B is, but the problem is from A to the middle of the circle all the way to right here is the exact same distance from point A to B. They're congruent, but the problem is since you travel that much distance, you have to travel much more distance to get to D. So therefore, from A to B, it's the closest. And point B is also known as the point of tangency. I almost said tangency, but now we're going to say tangency because that's the closest point from A to B when there is a line and a circle. If you wanted to find the distance here, you know that that's the same distance as from the distance to point A and B because you're basically grabbing that radius of the circle and moving it to basically wherever you want. Then you'll find out what this distance is.
Start.
Explaining how to find this distance and explaining how B is closer to point A and D is not the closest to A does not help us understand how this is perpendicular because what happens next is what we just made when we inserted point D on the line and made D and A have a line with each other. Besides the circle and the line, there's another shape that we have right in front of us. And yeah, it's a right triangle. So this right triangle is going to help us understand how these two angles are 90 degrees and how they are perpendicular because every time that you're working with a right triangle must have an angle that is 90 degrees and it sits just like you're sitting on a wall or besides a wall near the intersection of A and B. So if we say that if this right triangle is truly a right triangle, then it also means that it can prove that A and B, line A to B, and line C to B is perpendicular. Here's an example. So, this is our example. is the right triangle rightly a right triangle? Let's see. So we have from T to A, 12 units. From A to O, that's 16 units. And from O to right here, the circumference of that circle is 8 units. Is this the right triangle? So the first thing we can say is when we abstract, we can move that 12, grab the radius, and rotate it somewhere to match this line. We can say that from the line, the distance from T to A is congruent from the distance from T to that circumference. So we're going to say 12 right there. From point O to point T, we have 8 plus 12 because that makes the hypotenuse. Oh, and when you're working with the right triangle, it comes back to the Pythagoras Theorem because we have A squared plus B squared equals C squared. Or some schools like leg squared plus leg squared equals the hypotenuse squared.
Start. Finish.
So if 8 plus 12 is the hypotenuse, we can merge them to make a distance of 20. So now we can actually calculate what this is. Because is it a right triangle? So we're going to say 12 is length A, 16 is length B, and our hypotenuse is length C. Let's see what happens when we insert those numbers into the Pythagoras Theorem. So we have A squared plus B squared equals C squared. So our hypotenuse was 20 squared. And for A and B, we're going to have for A 12 squared and B 16 squared. So 12 squared plus 16 squared. That equals 20 squared. Is that true? Well, let's see what happens. So 12 squared, 12 times 12 is 144. 16 times 16 is 256. And 20 times 20 is a whopping 400. So when we add the two, we get 400. So does 400 equal 400? Or is it the same? If no, then this is not going to be perpendicular. If yes, then yeah, this is perpendicular. So 400 equal 400? Well, in this case, yes. So we have now proved that this right here is a right triangle. And it also means that line T to A to O to A is perpendicular. So, having the right triangle become rightly a right triangle can help us automatically find if this is perpendicular. That's with the length. But what happens if you don't have the length and you just have these random angles? Well, first of all, those angles look very cute because they're tiny and they're called acute angles. And earlier in the video, we said that when you're working with right triangles, you must have an angle of 90 degrees exact. So, what we're going to do here is when you're working with any kind of triangle, not just a right triangle, like an equilateral triangle, an isosceles triangle, an oblique triangle, which we'll learn about later in 11th grade. All of those sides, yeah, exactly all of them is going to equal 180 80 degrees. So what we're going to do is have 42 plus 48, and that's going to equal whatever mystery number is, equals 180, because all of them equal 180 degrees. So what is this one right here? What is angle TAO? TAO, tau. What is angle tau? Well, we said that all of them equal 180. So with these two angles, our mystery number must contribute to 180. So 42 plus 48, that's going to be 90. And whatever our mystery number is equals 180. Subtract that side by 90, subtract that side by 90, and we get an answer as 90. Well, look what we have here. 90 degrees exact. And that is perfect for a right triangle. So this is rightly a right triangle, which means that line TA and line OA is perpendicular again. So that is how you find if these two angles are perpendicular. And that is how we understand the tangent. Oh, and Emperor Zong, if you're watching this video, this is a perfect proof why your rugger dance carpet has circles and lines that are perpendicular. I hope this video has helped you. Thank you for watching Taoping Airlines Math Industry. Like and subscribe. And Sai Zhen. Have a nice day.